true and accurate?
I do.
Thank you. Mr. Dublinsky or Mr. Leonard, whoever.
Thank you, Your Honor. Mr. Godfrey, are you the same John Godfrey that caused to be filed in this case direct and rebuttal testimony?
Yes, I am.
Do you have any corrections to your testimony before we begin today?
No, sir.
If I asked you the questions in your pre-filed testimony on the stand, would your answers be substantially similar?
Yes, sir.
Your Honor, we move admission of Godfrey direct and Godfrey rebuttal testimony.
Are there objections other than Mr. Jordy's standing objection?
Yes, relevance, foundation, and speculation, specifically as to the rebuttal testimony.
Okay, thank you. Mr. Long, did you have an objection too? Oh, he's ready. Okay, the board will admit the evidence and give it the way due.
Thank you, Your Honor. We tender the witness for cross-examination.
Thank you. Mr. Long?
Thank you, Mr. Godfrey. My name is John Long. I'm an attorney with the Office of Consumer Advocate. Can you tell us the expected useful life of the proposed pipeline? Let me, from a technical and engineering perspective, not financial or business.
Yes, sir, and thank you very much. That is the focus of my testimony. The expected useful life of a modern steel pipeline is essentially indefinite with proper maintenance and operated within its operating envelope. There are pipelines in the United States now that are well over 100 years old.
Thank you. That's all of my questions.
Mr. Meyer?
Good afternoon, sir.
Good afternoon.
Can you tell us what the technical structural fail point is in terms of PSI for the proposed pipeline in a 6-inch pipe?
Not without knowing the grade of the steel and the wall thickness of the pipe in question, I could not.
All right, you don't know those, you've never been presented with that, you don't know those specifications for this proposed pipeline?
Not that I recall as I sit here today.
And that would be the same answer if I asked you about 8-inch or 20-inch or 24-inch?
That is correct.
In your experience, do you have, what could the range be?
There are pipelines in the United States now in CO2 service that operate up to 3,000 PSI.
I'm not asking about operating, I'm talking about what they could tolerate before they rupture.
Pipeline operating pressure is regulated by PHMSA. It's generally regulated at 72% of the specified minimum yield strength. Depending on the ultimate tensile strength of the material, rupture pressure would generally be 25 to 50% higher than the maximum operating pressure.
So if in this instance it's the maximum operating pressure is a little south of 2200 PSI, we would be looking at up to maybe 50% on top of that, so somewhere mid 3000 PSI?
Again, depending on the exact grade of the steel and the wall thickness of the pipe and any variations in it, that's possible.
Okay, and why don't we know what grade is being used yet?
I just don't recall that information. I don't believe I've ever been presented with all of the design details for every segment of the pipe in Iowa.
Okay, have you been presented with the design details for any segment of the pipe?
I believe during some of our conversations with Summit engineering staff that they've advised me as to the grade that they intend to use and the average wall thicknesses, but as I stated, as I sit here today, I just can't recall.
Is it safe to say that when those that have been tasked with putting together dispersion models have not come and knocked on your door and asked you for the fail PSI number?
DNV was not contracted to do any dispersion modeling or review any of the dispersion modeling for this project, nor were we asked to look at the maximum operating pressures or the materials that were going to be used.
Well, just then from an engineering perspective, can you tell me, can you guarantee that this pipeline would never operate at a pressure higher than the MOP?
Obviously, I'm not the operator, so I can't really testify whether I can guarantee it would be operated above MOP. But the regulations in Part 195 allow for transient events and upset conditions for a pipeline to briefly operate at up to 110% of MOP. Pipelines are designed with a safety factor of 20%. So they're initially hydro tested 20% higher than their MOPs. It is very, very uncommon for a pipeline in the absence of a defect to fail at its MOP.
Well, and that's words like uncommon, absent of a defect. Well, we have to, for purposes of creating a worst case scenario, so we can prepare for the worst case scenario, we have to assume there's going to be an uncommon defect occur. Fair enough?
I don't believe so.
You don't think we need to plan for the worst? We can plan for less than the worst.
I'm not sure I follow your question.
Well, what part of it aren't you following?
What you're asking in terms of planning for less than the worst, I'm not sure I understand what you're asking.
In terms of response, emergency responders, people in the community, we want to know what a worst case scenario is so we can do our best to plan for that catastrophic event. And so things like unexpected, uncommon failures are things we have to consider. And so do you have information that would allow for accurate dispersion modeling for responders then to have a better picture, the best possible picture of what a catastrophe could look like?
It's common for pipeline operators to consider a full guillotine break as their worst case discharge scenario. That's typically what's required of oil pipelines in Part 194 when they're designing their oil spill response plans. And I believe that is Summit's condition in their dispersion analysis and their planning, is that they planned for the highly unlikely event of a guillotine rupture.
Mechanically speaking, how does the pipeline stay within the MOP? And I understand that PHMSA can allow for some variation, but just mechanically speaking, how does the pipeline stay within that MOP?
Generally speaking,
Well, mechanically, what is governing that PSI?
pump selection, motor selection, pressure switches and pressure transmitters, typically high line pressures, high discharge pressures. Pressures located at valve sites, pressure transmitters, I should say, located at valve sites, at trap stations, other locations along the line, such as metering or custody or injection points. All of those locations are monitored. The pressures are monitored by the pipeline system, SCADA system, typically on the order of several times, or I should say within several seconds, usually 6 to 5 seconds throughout the day. Those pressures are fed back through the SCADA system to the control system, and those any pressure excursion that would be approaching MOP would generate alarms, and in certain cases would generate automatic shutdowns of the pipeline system.
And does that, do any of the scenarios account for sabotage?
Pipeline leak detection systems and pressure monitoring systems would be able to identify a sudden line break, whether it be sabotage or outside force damage or any other damage that would cause the pipeline to rupture. That would typically be picked up, as I said, by the leak detection or the pressure monitoring systems and relate to the control center.
Is there any way in which some sort of blockage could cause the pressure to spike rapidly, that would then cause a rupture?
It is possible to have a sudden blockage if, say, you were running a pig through the line or an internal inspection device. However, pipeline systems, including Summit, run transient surge models during the design, and they maintain those surge models during operation to detect any surges, and the systems are designed with relief valves and overpressure protection devices to mitigate those surges. So it's an eventuality that's designed for and designed around.
And I get it, there's maybe some redundancies built in to kind of help. If something fails, something else is going to kick in. Is that fair to say?
Yes, sir.
Do you know whether or not this project has contemplated or incorporated into it some sort of fiber optic external to the pipe itself that would pick up sudden changes in temperature?
Not to my knowledge.
Do you know whether or not that's feasible?
That's a very good question. There are some limited examples of very short systems that use that. It is available in the market. However, I'm not aware of any large transmission systems that use it across the breadth of their system. I think that it's been found to be impractical and difficult to manage over large scale.
Are you aware of any other projects that are also seeking permits that are actually intending to use a fiber optic detection so that when it'll reduce the temperature when there's a leak or a rupture, right? The gas escaping will suddenly reduce the temperature of the outside the pipe.
In the case of carbon dioxide, yes, it would.
That's what we're talking about.
Yes, sir.
And are you aware that any of your competitors or the others that are seeking permits for a CO2 pipeline are going to incorporate fiber optic technology?
I'm aware that Navigator is considering fiber optic technology. They have stated that they will use it in certain cases. I am not aware that they plan on using it through 100% of their system. But I do know they are evaluating it and looking at the state of the technology.
Do you think that would be something reasonable for this board to require in this project?
Not based on the state of the technology and the scope of this project at this time.
I don't have any other questions. Thank you.
Mr. Jordy?
Yes, thank you. And to close the loop, I would offer landowner 554-554, which is the deposition transcript of John Godfrey, and that's the last deposition to be offered.
No objections? All right, the board will admit.
Thank you. Sir, in your rebuttal, you talk about Richard Kuperwitz, and apparently you and he have tangled before, or at least been on opposite sides before, I take it.
We've both testified in the same hearings, yes.
Okay. But typically not on behalf of Summit, but typically on behalf of competing parties.
Yes.
And you included some comments in your rebuttal here relative to your disagreements with Mr. Kuperwitz, Dr. Kuperwitz, I think, and some of the statements and arguments he made. Is that right?
It's Mr. Kuperwitz, and I did rebut several of the statements that he made, yes.
Okay. Is it also Mr. Godfrey?
Yes.
And I guess I'll offer then 477 and 478, the Kuperwitz testimony that's being rebutted.
The objections?
I don't think so, but you offered two exhibits, one of which is Kuperwitz's testimony. What was the other?
It's just his paper that's
sure.
attached to his testimony.
Same objection about normally waiting until we have the witness here for cross. But
Okay, thank you. The board will admit and give the weight due.
And then, sir, you also respond to Bill Karam, and you understand he's with the Pipeline Safety Trust. Is that correct?
That is correct.
And then also you respond to Dr. John Abraham, and that's generally confined to modeling and different philosophies on dispersion and flume modeling.
That is correct.
I would offer 469 and 470 as to Bill Karam. Sorry, go ahead.
same objection.
Okay. Thank you. The objection is noted. The board will admit the evidence, give it the weight due.
And lastly, I would move to admit LO 474, the Dr. John Abraham testimony.
Same objection.
And once again, the board will admit and give it the weight due.
Sir, you also towards the end of your rebuttal testimony, provide some information relative to the concept or the phase supercritical and the phase liquid. Is that correct?
Yes, it is.
And you are certainly familiar with the concept of a critical point, which is the intersection of a value of temperature and a value of pressure, correct?
Correct.
And you are aware that supercritical fluid is a phase of matter that occurs above a certain temperature and above a certain pressure.
That is correct.
And would you also agree that liquefied carbon dioxide can only exist below a certain temperature, essentially 31.1 degrees Celsius or approximately 88 degrees Fahrenheit?
At the proper pressure, yes.
Okay, understood. And no matter what the pressure is, doesn't the temperature have to exceed 88 degrees Fahrenheit to get us into the supercritical liquid phase?
I believe that's the proper temperature without checking it, and I believe that's the temperature reference for pure CO2. That temperature is going to vary slightly with any level of impurities.
All right, very good. And so in any event, you're not disagreeing with the fact that in the phase diagram, if you will, of CO2, that the supercritical fluid is a separate category from CO2 in the liquid, solid, or gaseous phase.
That's correct.
All right. All right, can you believe it? I don't have anything further. Thank you.
Mr. Whipple, did you follow up?
Don't believe I've gone yet, Your Honor.
Oh, you're right. Sorry. Proceed.
Just a couple questions. Mr. Godfrey, are croplands considered higher risk areas for a pipeline than other lands?
Could you clarify what you mean by risk, sir?
By locating a pipeline in a cropland area, does it make it more likely for some kind of breach, release, or damage?
No.
And would you consider it arbitrary or unreasonable for a county to want to separate a pipeline from occupied structures,
Yes, I would.
no matter what the distance?
I would consider separating a pipeline from an occupied structure based solely on distance to be arbitrary. I don't think it takes into account all of the factors that go into pipeline siting or pipeline routing and could actually lead to unintended consequences.
Such as
encouraging or driving a pipeline route into areas of lower constructability, increasing the risk of construction-related defects, driving or encouraging pipelines into areas that are higher risk in terms of land movement or outside force damage. I think that when a pipeline is routed, a number of factors are taken into consideration. And the primary driver of the route is to ensure the pipeline can be safely constructed, it can be safely operated, and it can be adequately maintained. So I think just focusing on purely the highly unlikely of a release and a worst case discharge with worst case weather events and setting setback distances based on those is contrary to pipeline industry integrity management practices.
So what you're really saying is only the pipeline company knows the right place to put it.
No, there are many factors, and it's a collaborative process with different agencies when siting a pipeline. Mr. Rory testified to that earlier. He testified to the number of, and Mr. Schmidt, to the number of surveys that are done, the number of factors that are considered. All of those are taken into account when siting a pipeline.
Is it a collaborative process with counties?
I believe it is. Typically, dealing with counties on siting is not a core function of my job. But I would say that, obtaining conditional use permits, working with counties on things like access roads, road crossings, that would all be considered as part of the siting process.
And you agree that all of those things, from setbacks to road crossings, are part of the siting and routing process?
As I said, I'm not agreeing with arbitrary setbacks.
That's not what I asked. All of the things you just mentioned are part of the process of siting and routing, correct?
They can be, yes.
Do you consider it arbitrary for a county to want to protect future development?
Could you define what future development entails and what you envision it to be, please?
Whatever is in the county's comprehensive plan.
I object, Your Honor. Probably should have done this last question, but arbitrary is a legal term of art, so he's asking for a legal conclusion from the engineering witness.
You can answer to the extent that you understand or that you can.
Thank you, Your Honor. Could you repeat the question, please?
So you've already testified in response to a couple of questions that you don't consider, or you do consider certain things arbitrary that other permitting agencies might do. And I don't ask you to play lawyer. I only ask you to talk about from your standpoint, your expertise about where is a safe place to put a pipeline. But you have acknowledged there are other reasons and other entities with a stake in where the location goes. So I'm just wondering what you consider arbitrary.
I think I testified earlier that setbacks based on the distance of a highly unlikely release event, I would consider arbitrary in the routing process, and that's what I was referring to, is setbacks based solely on, say, pipe diameter, setbacks from certain residences or places of congregation, those sort of things. If it were based solely on a distance, I would consider that arbitrary.
What if the reasons have nothing at all to do with pipeline characteristics whatsoever, but with the plan a county has for its future development?
It would be, I'd have to look at what the specifics were to that plan. I'd have to understand that plan to make an opinion on that.
That's all I have, Your Honor.
Okay. Any other questions from parties? Okay. Board?
Mr. Godfrey, on page 3 of your direct testimony, you use some terminology I just want to make sure is accurately reflected in the record. So can you describe what a ductile fracture is?
Yes, ma'am. A ductile fracture is a fracture in the pipe body that is ductile in nature as compared to brittle. It's where the pipeline is overloaded, the steel is overloaded, and it fractures in the area of that high stress.
And what is a fracture arrestor?
Fracture arresters are devices or specific pipe configurations that are designed to stop or arrest any sort of a running fracture or a fracture that's propagating down the pipeline.
What would that look like on the pipeline?
It could be a area of heavier wall pipe. It could be a heavy wall fitting. It could be a composite wrap around the outside of the pipe to increase its strength and slow down the crack tip. It could also be a welded steel sleeve over the pipeline. Anything that basically increases the localized strength and blunts that crack tip so that it won't progress beyond the arrestor.
And how do you determine the appropriate location of those arresters?
That's done by the pipeline operator during design. Most modern steels are not susceptible to running ductile fracture. This is most common with CO2 pipelines that are converted, older pipelines that are converted in service. Pipeline operator will generally, in their design documents, specify the maximum distance between arresters or maximum distance of susceptible pipe. Generally, that's 2 or 3 pipe sections, so maybe 120 feet. Now, I say that generally, that's based upon DNV's work and our published recommended practice.
Okay, thank you. On page 5, lines 2 and 3, you state that Summit Carbon will conduct an AC interference study. I think this was with respect to the cathodic protection. Can you describe what the AC interference study is?
AC interference is where an alternating current remote from the pipeline, such as a high-tension power line, can induce an alternating current electric field into the pipe. That, much like standing underneath a high-tension power line and you touch your car door and you get a slight shock, linear assets like pipelines, that current will build on the pipeline until it finds a place to escape. That escaping current can lead to metal loss and corrosion. AC interference surveys look at areas where potential AC is around the pipeline, and we'll go out and measure the AC effect on the current and then design mitigations such as ground beds, diodes, bleed points to take the AC current off of the pipeline.
In other testimony about other aspects of the project, Summit has, I think some witnesses have stated that Summit will be applying high consequence area criteria to the entire pipeline in some instances. So we wanted to clarify on the mainline valve placement, will those be a mixture of 15 mile and 20 mile, or would you be going all with the HCA distance of 15 mile?
I'm not exactly sure. That's a better question for Summit. However, when they're applying the HCA criteria to the entire pipeline, what it means is the entire pipeline is going to be under their integrity management program. So their inspection or assessment schedules will be the same, whether it's a HCA location or not. They're going to apply the same repair criteria, the same repair response times, the same requirements for preventive and mitigative measures. I just can't recall and can't testify today as to the valve spacing, other than they've made a commitment to meet the newest PHMSA proposed regulations, which are greater than what's required right now.
Thank you. So you did mention the Satarsha pipeline incident in your testimony. Can you speak to the lessons learned from that incident, including PHMSA's recommendations?
Yes, ma'am.
So what safeguards would Summit have in place to avoid a similar pipe failure?
The primary cause of the Satarsha failure was earth movement. The pipeline was overloaded and failed at a girth weld due to very heavy rains and subsidence along the roadway. Summit has undertaken, in response to the PHMSA advisory bulletin that was issued after Satarsha, they've undertaken geohazard studies for the entire pipeline route. I understand those are still in progress, and they're committed to completing the geohazard studies and abiding by the recommendations in PHMSA's advisory bulletin. That was the primary root cause of the pipeline failure. Secondary to that was a condition where the pipeline girth weld was undermatched compared to the pipe steel. In discussions with Summit's engineering staff, they have indicated that they are using modern pipeline steels. They're having those steels designed and the pipe specifically manufactured for this project, and are taking that into account as well.
And can you speak to at all how, if a similar rupture were to occur, how would Summit's response be different?
Are you asking me to comment on their emergency response plans?
Anything that you would have knowledge of that would be different in the, not just in the design and placement, but on the response side?
Yes, ma'am. I think the entire industry has learned from Satarsha. You know, the lessons learned have been subject to not just the PHMSA investigative report, it's also been subject to PHMSA public meetings. It's forefront in all of these hearings. I think that, you know, the entire industry has been attuned to the response failures at Satarsha. And that includes the need to inform local emergency managers. It includes having proper air monitoring and detection equipment for emergency response personnel, and proper education to the public.
Thank you. I don't have any further questions.
Yes, ma'am.
Just a couple quick follow-ups here, Mr. Godfrey. First, you piqued my interest a little bit. You said something about taking older pipelines and converting them to CO2 pipelines. So older pipelines that were using what, or what was going through them as a product, or can you expand on that just a little bit?
It's not unusual in the pipeline industry over time, as markets change and as demand changes, for pipelines to be converted. PHMSA refers to it as conversion to service, so conversion from one service to another. Natural gas pipelines can be converted to oil use, oil back to natural gas, or natural gas or oil lines converted to CO2 transport. It's those older vintage pipelines, not designed and manufactured with modern steels, that are more susceptible to ductile fracture. That's kind of the primary threat, and that and emergency response planning, understanding and updating their ERPs. But a lot of those concerns, this is a greenfield project, so they're not a particular concern here.
So, I know yesterday there was conversations about the operating pressures. Today we have conversations about the operating pressures. And I think, if I understand Mr. Meyer correctly, what he was getting at is, how do you prevent an accidental ramp up? And I think I heard you say something to the effect of, equipment can make a difference in that. So I was thinking about this and I'm like, well, if I don't want my 25-year-old daughter to lose her driver's license, I'm going to put her in like a 71 Ford Pinto versus a Dodge Hellcat. Is this similar to what, you can't reach this unsafe pressure if the equipment is not sized large enough to reach that? Is that what you were saying? Is that the equipment?
That was my first point, yes. The first line of defense is size your pumps correctly. These systems work with centrifugal pumps. They have shut-in pressures. So by pump design, it doesn't have an unlimited ceiling. It just has so much pressure it can put up, and that's it. It's like your 71 Pinto with a governor on it. It's not going to go any faster than 71 miles an hour. That's kind of the first level, is proper pump selection and pump sizing. And then you have relief devices, engineered devices that prevent pressure surges and pressures from exceeding the MOP. And then you have your instrumentation and your monitoring that provide for either automatic shutdown of the pumps or alert operators and controllers so that they can respond to any overpressure event. So it's really 3 different layers of protection outside of the design of the steel itself. Sizing of the equipment, sizing of the relief devices, and then your instrumentation and your monitoring.
And so, on the electrical side of the world, and, we don't, as a board, we don't just focus on gas or pipelines. We do electric, we do water, we do all sorts of things. One of the things that has also kind of piqued my interest a little bit is cybersecurity. And I've read enough research that talks about, the fear of cybersecurity attacks on, whether it's the grid, could be on a generation system where they get into the generator. Basically, they cause the generator to max out, blowing up the generator. And I think Mr. Meyer is alluding to this as well, is, the cybersecurity. What preventative measures so that somebody can't attack the system and ramp up those pressures? And are you telling me that based on the equipment size that's going in, even if they did hack the system, they physically cannot get that system to that maximum operating pressure?
You're not going to get the pump to go any higher than its design pressure. All right. And to your point around electrical systems, the pumps on the Summit system are going to be electrically driven, is my understanding. If an electric motor starts to overspeed, it also has protections on it for winding temperature, speed control. In the motor control center, that will also automatically shut down a pump.
I appreciate the responses, Mr. Godfrey. That's all I have.
Thank you, sir.
Thank you. Is there a redirect from Summit?
No redirect, Your Honor.
All right, thank you. You may step down, Mr. Godfrey.
Thank you, Your Honor.
Okay. We're going to take a 15-minute break. We will come back and do Mr. Bentz. As soon as Mr. Bentz is done, we will pivot to Mr. Powell. I think that should be enough. Hopefully we can get all that done. Any questions? Okay. See everybody in 15 minutes. Oh, Mr. Whipple. Second time today I missed you.
So sorry, counties have a number of witnesses here.